Hello, my name is Madhat Abdel-jawad. I'm going to talk to you about an accident investigation that I led a few years ago. This accident resulted in a fatality and more than 12 injuries, serious injuries. A few of them were in the ICU for more than 2 or 3 weeks. Um, it's an explosion that occurred in a tank that was used for storing crude oil. And the important thing that I want to stress here is that had this material been not crude oil, had it been diesel, it would have been the same outcome, if not worse. Had it been any flammable liquid, it probably would have been worse than the crude oil. It's quite hard to believe that crude oil can explode, but you will see that it is eminently possible with any oil, any type of oil, to get an explosion, and a serious one at that. Okay, let's talk about this event. Okay, the tank first is a dewatering tank. Very simple. You can't get any simpler than that. It's got a oil inlet, an oil outlet, and a water outlet. So the oil inlet will let the raw crude in. The water will settle to the bottom. The water will come out from the bottom through the water outlet, and the dewatered oil will come out through the oil outlet. And of course, there's a gas outlet for vapors that come out. Simple as that. This tank, so obviously the water settles at the bottom, so the water will stay at the lower end of the tank. And as the well gets older and older, the water level will rise higher and higher, obviously because they pump in water to get more oil out of the well, and so there's more water content. Therefore, the level of the water in the tank becomes higher. So the corrosion protection on the inside of the tank was only up to a certain level. And when the water level obviously went above that after many years, the corrosion protection was not functioning there. So a leak sprung ultimately due to the corrosion from the inside. Here's a picture of the three tanks before the accident, of course. That's the actual tank. It's called Tank 804. These are huge. They're 35 meters in diameter and about 15 meters high. I'm only going to summarize this event, by the way, because obviously it was a very involved accident investigation. It was a very detailed accident investigation. But I'm going to summarize what happened as a sort of learning point, and we could probably talk about this in more detail if we have a lunch and learn session or something. And you can contact me about this. So this is what the base of the tank normally or should look like under normal conditions. Uh, and before we get to how it looks after, let's look at a series of events that occurred. So a leak due to internal corrosion occurred in the tank. The tank was taken out of service. It was drained, isolated, opened, deslugged, sandblasted, painted, coated, and then they removed the sand from the tank. They jet cleaned it. So, I mean, it was spotless. They NDT tested the tank, and then they sent a few guys over there to do some work. So, first, they fixed the leak from the outside, they fixed the hole that was resulting from corrosion from the outside. And then four workers went into the tank to uh, do some hot work on a pipe that was inside that tank. It was a dead leg that was part of the oil outlet. Um, the what happened thereafter was recorded by several witnesses and cameras and so on. The tank exploded. One guy was shot out of the tank, and he hit his both his legs on the bund of the tank and broke them and landed on the other side. And that actually saved his life because the other guy didn't hit the bunt. He missed the bunt and he was shot out of the tank, out of the manhole, 80 meters. And he landed and died. And they couldn't find him for an hour. They only found him after they examined the security footage. Um, so how did this happen? I mean, the tank was clean. The tank was sanded. The tank was jet cleaned. This is how the tank looked after the accident happened. Of course, there was an explosion and actually a very big fire that occurred afterwards. You could see part of it, part of the sort of soot from this side. Of course, the other side was very, very black. And of course, it's sitting lopsided. This tank, this tank, 380,000 kilograms, and it was sitting on a concrete ring that was about 180,000 kilograms, so half a million kilograms in total, took off, literally took off. The floor sheared off, and the tank took off and rose for at least 3 or 4 meters. And then it landed on a different location to where it took off. So it moved a few meters. And the way we know this is that there was a concrete pylon outside the tank before the accident. The concrete pylon was inside the tank after the accident. It was still attached through pipework to the other two tanks, by the way. So this could have been a much bigger disaster that involved the other two tanks and interrupted the supply to an entire country. Okay, so this is a picture of the concrete ring pulled out of the ground. This should usually rest inside the ground. This is the foundation of the tank, and that's the tank there. Obviously, the base is not how you saw the undamaged version a few slides ago. And here's the floor of the tank, sheared off like the top of a can, top of a tin. And that's another picture of that concrete foundation. And this is the tank here. Yeah, another picture, and you could see that the tank has moved off the foundations. These bolts were sheared at a 45-degree angle. They were all sheared off. So it's a huge amount of force that were involved. This is a picture taken from the inside of the tank. That actually, you're looking at the oil outlet here. And it's got a funny design. You've got these two dead legs here. I think it was designed to control turbulence. And also notice that there is an oil stain here and here. It's actually one big oil stain, but it's actually bigger here and here. This unusual shape and an unusual piping arrangement, admittedly. The size might be misleading of this thing. This is 7 meters long. So this guy is 6 foot tall, more than 6 foot tall. And you can see how small he appears compared to one of these dead legs. This is just a part of one of these dead legs. That's 24 inches and 7 meters long. And that's the tiny little hole that they were working on when the tank exploded. Actually, the guy heard a hissing sound and then suddenly told his guys to run. He had been uneasy about this job for a reason he couldn't quite put his finger on it. And when he heard a hissing sound, he told everybody to run. And two guys remained in the tank when it exploded. These guys were only alive because they were wearing, flame retardant gear. They would definitely be dead. And they spent um, more than a couple of weeks in ICU, in the intensive care unit, and 12 guys outside were injured from this explosion. There was a 200-kilogram sand bag that was shot out 100 meters. And as I said, one of the workers had gotten near the manhole when the explosion occurred, and um, and he was shot out also 100 meters and died. So how did this happen? I mean, and you could see the stain here, by the way, the oil stain, very clearly on this thing. So this is the color of the tank, but this is whitish sort of oil stain. What happened? The tank was clean. The tank was sanded. The tank was jet cleaned, NDT tested, drained, deslugged. Uh, where was all this energy coming from? Yeah. I'm going to summarize. Obviously, it was a very involved accident investigation, so we won't go through all the sort of avenues of investigation, but rest assured there were many, including the possible release of all the oxyacetylene from the oxyacetylene tank, as implausible as that seems, because if there had been a leak in his oxyacetylene line, if he was leaking acetylene into the tank, he would have noticed from his torch that it would have been weak. But assuming that he was, completely out of not focused, still you couldn't possibly get this type of explosion using the acetylene from a little tank uh, if its entire contents were emptied into this massive 35 diameter tank. So we had to look for something else, and we looked at other avenues as well. Now, for the inlet, the outlet, and the oil inlet, the oil outlet, and the water outlet, they had dropped the spool, drained the contents, spaded it. So those pipes were empty. But the outlet, remember, we had a strange design. Remember how it looks? It looks like this. Yeah. So it's a 24-inch pipe, and this is the common main that goes out of the tank, and the spool is dropped outside the tank, and then it was spaded, and so it was blocked. But and obviously it's lopsided now after the accident, but if you look at the if you look at the if you reorient it and have a look at at how things are, you're draining from this pipe here, and actually this has two dead legs that are actually below the drainage level. So if you look at it schematically, each dead leg would contain a certain amount of oil, crude oil, and this was estimated at about 1,500 kilograms per dead leg, so 3,000 kilograms in total. And obviously there'd be residue on the inside, oil residue on the inside, and that's highly flammable. Even though there were months between the decommissioning of the tank and the cleaning and the accident, and some weathering of the oil would have been expected. But at the same time, bacterial activity, especially if water got in here, would produce some methane. And so this pipe, this is the main common pipe that goes out of the tank and goes out of the page, if you like, that is blocked at the other end, and there is a flammable mixture sitting here. By the way, the flash point of the crude extracted after the explosion, after the fire, was 69 degrees Celsius. And like I said, there was a flammable gas. So what would have happened was this guy was cutting with his oxyacetylene torch, and he would have set some of the residue on fire. And that's not enough to cause an explosion. But what would have happened was the flame would have traveled down and then ignited the crude, and then traveled along the crude that was sitting in the dead leg like a pool fire, and then reached this region here, which is blocked off, spaded, um, and then ignited and produced a gas explosion behind the slug of crude. And so that would push the crude out of this dead leg and produce the like a mist cloud of oil. So it's a cloud of oil mist. So even if it was a lean, weak explosion behind this crude oil, the result is, because it's so confined, can reach pressures of about 0.4 bar, and it acts for a fairly long period of time. So if you have at least 0.4 bar in this area, how does this slug react? Well, this slug Um, we did some computational fluid dynamics, basically a simulation that models how liquids behave with the pressure behind them. And we applied this time history behind crude, and this is how it looks. So it actually, as you would expect, pushes the crude out. And funnily enough, you get these distinctive shapes that we saw on the side of the tank, the crude oil tank. And this, remember, we're looking here at volume fraction. So this is a low volume fraction, 5%, which means that the liquid here is 5% of this volume. It's tiny little droplets spread out over this cloud. And when you atomize any fuel, crude oil, olive oil, if you like, and certainly diesel, you get a very powerful explosion. We can show you experiments of how um, an oil mist explosion behaves. Here's the oil mist, and it's going to be ignited. Quite powerful. And you can make it more powerful. And so, by sort of modeling this explosion, you get the overpressure the overpressure in the tank can be calculated. What's interesting here is that the tank is huge. The tank is so huge and has very little um, venting area. And so the pressure that developed took a long time to vent out of that tank. And that means that it acted over the tank for about 30 seconds, which is a huge amount of time. The impulse, the energy delivered to that tank is the area under that curve. And this is almost unheard of, this huge amount of time under that curve. And so that produces a lot of damage. Now, the tank was supposed to have a frangible roof. And when you have a tank with a frangible roof, if you have any pressure, the roof just pops off, breaks off, not entirely, but just breaks off, relieves the pressure, and then nothing happens. It saves the situation, if you like. However, there are 7 different, or 8 actually. It's a API 652 standard for tanks that are um, with frangible roofs, and there are 8 conditions for that. And this tank only fulfilled 2 of the conditions, even though it was claimed to be a frangible roof tank. And so instead of the roof breaking off, the floor sheared off. And this simulation, this finite element simulation, shows that in fact the stress concentrations, if the roof was rigid or stronger than the floor, then the floor will shear off indeed. And so once you've got the floor off, the tank will take off. And you wouldn't believe how little pressure it takes to lift a tank of that size. It's only 0.05 bar. That's a summary of the explosion that happened. We could talk about this in more detail, but remember, the point to take away from this is the atomization of any fuel, including crude, including diesel, is a great way to get it to explode. And they, in fact, for diesel, that's what happens in diesel engines. You atomize it, and all you have to do is compress it, and the air around it gets hot enough to ignite that diesel, and it's an explosion. Um, thank you. My email, by the way, if you want to get in touch with me, is that. If you wanna talk in more detail about this.